Welcome back, YouTube. Let's do C6X9d. We're going to do the Newton method class using big decimals to represent our numbers instead of doubles. Doubles are fraught with round-off error, and you can't really write out a decimal which has a lot of digits after the decimal point in exact form. But that's what big decimal is for. So we're going to talk about the big decimal like we did big integer. Big integer was an immutable class with as many integers in front of the decimal, or as many digits in front of the decimal to the left of the decimal point as you want. That was an immutable class. I don't know if you noticed there were no mutators, so if you do a calculation, you have to store it somewhere or print it out right away, whatever you want to do. Same thing with big decimal. And if you take a look at the Java API for big decimal, it's a lot easier to construct a big decimal as a string than it is with a double. You can use doubles, but again, it's fraught with round-off error. Okay, so let's try and do decimal arithmetic as exactly as possible in Java. That's the idea. All right, so here we go. So let's make a terminal or a shell. Let's cd to the YouTube directory and lab6 directory. And, well, that's it. And then let's make dir. This is where we want to be, right? Yes, let's make dir C6X9d. There you go. And cd there. And there's nothing there. Okay, good. All right, let's get an ASCII editor or text editor in here, or what they call a new file. Okay. Well, you know what? I'm not even going to do that. I'm going to, like last time, I'm going to copy. Yeah, I'm going to copy stuff from C6X9c. All right, so let me get out of here. Let's copy from C6X9c star.java to C6X9d because it's very similar. There you go. Okay, there you go. Now I'm going to call this one FindPhi, or BigFindPhi. Okay, so let's move or rename. It's called move because you could also, the name of the file includes its path where it's stored, so you can change the path where it's stored so that you move it to another directory if you want. But let's do move and leave it in this directory. So just change the file name. Instead of findE.java, I want BigFindPhi. BigFindPhi. So it's FindPhi, but with big decimals. .java. Well, that's what I want to call it. I'm going to move it from findE.java. There you go. And by the way, is it over here? BigFindPhi.java. Okay, and then there's findE tester. I want to call this BigFindPhi tester. All right, so, whoops, get over here. So, let's change it from findE tester to BigFindE tester. So I'm going to make it tester. That's what it is. FindE tester. Yeah. So we're finding phi or phi, the golden ratio 1.618ish, right? And these are roots of the polynomial x squared minus x minus 1. And the derivative of x squared minus x minus 1 is 2x minus 1, right? That's all we need to know. And how big decimal works. I'll show you how that works. So BigFindPhi, BigFindPhi tester, right, exactly. All right, so let's open up the tester. And let's open up the class. Now, the tester is almost identical except for labeling the name of the file. So I'm going to call this BigFindPhi tester. All right, so I got to copy this, change this, but let's get rid of the tester part. Change this and change this, but get rid of the tester part. No, that's not right. We keep the tester part. Okay, good. And then this. And what we're going to do is we're not going to input from the, we are going to input from the command line, but we don't have to parse it to a double, I want to pass it as a string. So instead of x0, it's going to be arg0. Well, this should say x0 and then EPS, right? Okay, so this should be arg0 instead of x0. And this will be args1 instead of EPS, right? So args1. And otherwise, we're done. Oh no, I got to change this to find BigFindPhi. So basically it's the same test, and we're passing string because it's easy to construct a big decimal from a string representation of that decimal. So I'm going to leave it like that. All right, so now here we want to call this BigFindPhi. And so I'm going to copy that. I'm going to put it here, and I got to put it here. But now this is a string, and this is a string. Okay, and then this is going to be about. Okay, how about we make everything a big decimal in here. Whoops. So I got to do this dot EPS equals. Well, I'm gonna do this dot this time just for fun, just to be different. But what I'm gonna do is I'm gonna make a new big decimal using the inputted EPS value. All right. So now what's nice about this is that BigFindPhi is a class that has private instance fields which are objects from other classes. So BigPhi has a big decimal, which means you have to declare it in your private instance fields, but then you have to construct it in your constructor. So instead of making old guess equal to 0, I'm going to make it old guess equals a new big decimal equal to 0. Or how about we just say it equals a predefined static final called BigDecimal.0. How about that? All of which you can figure out if you look at the Java doc in the Java API for big decimal. Oh, and we have to import java.math at big decimal, like we imported java.math at big integer, right? And then here we're going to construct a new big decimal out of x0. There you go. Which is a string. Okay, that's fine. What else? That's that. Oh, I'm also going to need a value, a big decimal value for 2. So I'm going to create. Let's see. How about one more? Let's put in one more private instance field. Private big decimal. And I'm going to think of it as a final 2. That's why it's encapsulated. It's not really a final. And then we're going to, there it is declared, right? An object from another class. So now we've got to say 2 is constructed as a new big decimal number, equal to 2. And I'm going to use quotes. Another string, okay? All right, so then this doesn't change, or does it? Wait, let me think. Oh, yeah, the absolute value function. Okay, we're going to take, okay, we don't have a minus, we have to subtract. So we have to do new guess, dot subtract old guess. So let's change that. Dot subtract, sort of like we did with big integer. Subtract old guess, right? And then that quantity, we need to know the absolute value of it, right? So I'm going to say dot absolute value of it. And there's no greater than. It's also, there's no dot equals either, but there's a compare to. So if I do this dot compare to EPS is greater than 0, would be the same thing. Remember how compare to works? Dot compare to. So the comparable interface is being implemented. in the BigDecimal class. Okay, compare to EPS, and if that's greater than 0, that's the same thing as saying that EPS was less than that difference. Okay, good. I think that's what we want. Okay, we'll debug it in a minute. Don't forget to import java.math.BigDecimal. So you can look it up in the API on Oracle there if you need to. But I think I got all the details here. All right, so now what are we going to do? Well, this is what has to change. Okay, old guess equals new guess before we change the new guess. That's good. Then the numerator and the denominator. All right, now here's where it gets really crazy. New guess equals old guess dot subtract that, right? So dot subtract, not right. We don't have subtraction symbols or operator, right? So subtract. Too bad we can't overload operators like we did in C++, and we can't pass functions like we do in Python. Well, instead of rewriting the function here every minute. Okay, so subtract num divided by denum. But wait, dividing is weird. It's going to be num.divide. Okay, dot divide. Okay, there you go. But then you have to say how you want it to round off if it's, wacky decimals. It's going to be some weird irrational number. So let's say I want to round it off to, I don't know, 4 decimal places. And then I have to tell it how I like rounding off. Well, I'm going to round off, if the next digit is 5 or more, I'm going to round up. So I'm going to say BigDecimal dot round. This is a predefined final. Half up. There you go. And that's it. Okay, now we got to change the function. Now the function is x squared minus x minus 1. So how are we going to do that? We're going to take the old guess, right? We're plugging in the old guess to get the new guess. So I'm going to do old guess dot pow2, and it allows you to put in an integer or a double here, and it'll work out fine. It'll convert everything to big decimals as needed. All right, comma, or I could use the big 2, I guess. Subtract x, which is just old guess, dot subtract 1, dot subtract 1, but there's a final, predefined final in BigDecimal class called BigDecimal dot 1. You can look all, you can just look all that stuff up. Then here's where we needed the 2, because the derivative of x squared minus x minus 1 is, by the power rule, what is it, 2x minus 1. So I need to do a 2x minus 1 here. So I'm going to say 2 dot multiply, I don't know why they don't call it product, old guess, so 2 times old guess, or 2 times x. Okay. And then minus 1, so dot subtract, again, that big decimal static final 1. Aha. And I think now we've got everything. So we're finding the roots of x squared minus x minus 1. One root is 1.618, and the other root is negative 0.618. And that's, if you play around with the golden rule enough, you'll find that big phi is 1.618, and little phi is the reciprocal. 0.618 is 1 over big phi, so the other root is negative little phi. We call that negative 0.618. We're going to calculate. Well, depending on where we start with x 0, I'm going to try and get the 1.618. All right, so save that, and let's see how we do. Let's test it. Okay, so we got everything here. That's basically the whole kit and caboodle except for the return line. Alrighty, and then here's the client class and the tester class. It's almost the exact same thing, but we're just passing the string straight from the command line. These are strings. Because it's a string array, right? Static array. Okay, so here we go. So, alright, so Java C, BigFindPhi tester.java. Alright, what syntax did we mess up? Oh, what'd I do? I got the strip from my notes and everything worked fine. What happened? Required double, found a big decimal. Where? Here? Huh? Wait, what happened? Line 26 in BigFindPhi. Line 26, so right here. Let's see here. Oh, this is not a double. This is a big decimal also. Uh-oh. And this is returning big. Oh boy, bad. Okay. This is returning a big decimal. Whoopsie. Big decimal. And it's calculating big decimals. So this local variable has to be big decimal, this one too. Because we're dividing big decimals. Right, okay. So save that. Is that what it was? Let's see what happens now. And good. Okay, so this should run fine if I say x0 is 1 and my epsilon is 1,000th. And get rid of the C in Java C. And okay, there you go. But do you want to get more precision? Well, now here's where we got to change stuff. We got to change. All right, so that's good for within 1,000th. Okay, so what if we go crazy? What if we make this good to type out like 40 decimals, 40 digits after the decimal point? Aha! Now let's see how crazy we can get. We're going to have to Java C everything because I just changed the code. There you go, good. And let's run it. Where's my Java line? Java line. Holy moly, where did the Java line go? It's in here somewhere. Okay then. Well, let's just write it. All right, so let's say 1 and 1,000th, and let's get rid of the C. And okay, now, so look, we got better than 1,000th place. 10,000s, 100,000s, almost a millionth place. Okay, let's make it good to the millionth place. All right, so tenths, hundreds, thousands, 10,000s, 100,000s, million. Well, that's a little, well, within one of the millionth. So the millionth place isn't necessarily correct. It's within one unit, right? So it's good up to the 100,000th place when I put in a millionth for EPS. Okay, that's good. Let's make it even better. Billionths place. Just converging all the way over. Well, sometimes you get even better convergence, right? So up to here. So what's that? Thousandths, millionths, billions, 10 billions, 100 billions, trillions. We got up to the trillions. Okay. And all right, let's make epsilon a trillionth. And did we get any better? Let's see, we got up to, everything was converging up to the 9s, and it's still no good. Okay, quadrillionths epsilon. Let's see. Oh, yeah, look, all this. Oh, look at all this. Whoa. All of this is converging all the way up to here. What's that? The thousandths place, millionths place, billionths place, trillionths place, quadrillionths place, quintillionths place, sextillionths place, septillionths place, almost the octillionths place. So the 100 septillionths place. Let's make it better. Do we get any better? No. Same. Okay. Let's try some more. And we get any better? I thought we could get better than this. That's odd. I thought I got better than this last time I tried it. Well, I guess it's as good as we're going to get. Oh boy. Right? This is matching up to here. That's odd. Oh wait, I got it. There it goes. All the way to the 40th decimal. So, thousandths, millionths, billionths, trillionths, quadrillionths, quintillionths, sextillionths, septillionths, octillionths, nonillionths, decillionths, unidecillionths, and duo-unidecillionths. Or maybe one more place. But, you know, we don't know if we trust that last place, so up to here. Duo-decillionths. That's what it is. Right. Okay, we're done. And so that's how you use BigDecimal. So I hope that was instructive for you. Now, big integer and big decimal are not part of the BigFindPhi.java subset, but they're good to know. Especially if you're doing like exact calculations with currency. You don't want round off error. You want exact values, you know, stuff like that. All right, and there you go. So that's it. Bye-bye, YouTube. Have a nice day.